Hi, and welcome to Always Eclectic Stacy. This is 5-minute chemistry where you learn chemistry concepts in 5 minutes or less, whether it be a brand new concept or an example. Today we're in the Ionic compound series where we're taking the name of an ionic compound and moving it to a balanced compound. And the example we're working with today is cobalt 2 phosphate. Ready, set, let's balance. Hi, and welcome to Always Eclectic Stacy. Today we're balancing cobalt 2 phosphate in 3 different ways. Now remember, you don't have to know each of the 3 different ways to balance. You might be really struggling on one way and really understand the other. So please, of these 3 different ways, really choose the one that works best for you, and then we can go from there. Now, the first thing that we always do, no matter which method we're using, is we're going to identify the cation and the anion. And the other thing we need to do is make sure that it is an ionic compound. Now remember, an ionic compound is both a metal and a nonmetal, and that nonmetal may also be a polyatomic anion. So we can look at this. Cobalt 2 is a metal. It's a transition metal because we're given the charge in Roman numerals, and phosphate is on that polyatomic anion list. If you're struggling with the polyatomic anions, please go ahead and check out my video on those. So the first thing we're going to do is identify my cation. It's cobalt 2, and that 2 tells me the charge, so it's CO2+, and then we're going to go ahead and write down phosphate. We know that it's going to be a compound because of the 8 with oxygen, and it ends up being PO₄₃-. Now, the charges aren't the same, so we do have to balance them. So I'm going to show you the the crisscross method first. So for the crisscross method, you're going to go ahead and write both items down, or both ions down. I shouldn't have said items. And you're going to go ahead and make the superscript, that number that flies high like Superman, like the 2 and the 3 on cobalt and phosphate, the subscript, the one that goes below, or subterranean, sub meaning below, of the other. So this 3 becomes the subscript of cobalt, and this 2 becomes the subscript of phosphate. So we end up with CO, and that should be a small o, because big C, big O, carbon monoxide, and that'll kill you. Big C, little o, cobalt, a pretty blue stone. 3, and then phosphate. Now, we need more than one of this compound, so we're going to go ahead and put it in parentheses because we want 2 of this entire compound. The parentheses are like a copy mechanism. You put it in parentheses and you go, I want 2 of this entire compound. Please do not distribute. That will make bigger problems for you because you start changing the identities of the items in your compound. We're going to do the LCM method. This has to be my favorite because it automatically reduces for you and it makes you stop and think, do I need a parentheses here? It builds it all in. So the first part of the LCM method is to go ahead and do CO1, PO4. So we're going to write our elements on the outside, and then we're going to start our equation. The first part of the equation is always your element charge. So the element charge is 2. We do not care if it's plus or minus for this method. This becomes 2, and the element charge of PO4 is 3 minus, so the number that is distributed with that is 3. Then you're going to make your equation 2 times something and 3 times something, and this something becomes your subscript equals your LCM, which is the lowest whole number they can both go into and remain whole numbers. Between 2 and 3, the LCM is 6. So then the subscript is whichever makes this number true. So 2 times 3 equals 6, and 3 times 2 equals 6. Now, when you're doing this, please keep in mind that if you have a compound out here and you have something other than a 1 here, you're going to go ahead and just automatically use those parentheses because it automatically reduces it for you, and you can visually see when you need parentheses. So we end up with CO3, PO₄². The last method is the equation method, and if you haven't quite learned equations yet, this might seem a little daunting for you. If you have learned equations, it'll make a lot of sense. It might be a good way of looking at ionic compounds. So for the equation method, you're going to set up these two items, cobalt plus phosphate, as an equation, a chemical equation, to balance it. So you have CO2 plus, and you're adding that to PO₄3 minus. And that's going to form a balanced compound. The idea is, in the equation method, you're thinking, how many of each do I need to make it a zero-sum game, as in the balanced compound will not have a charge. Now, with 3 and 2, you know you're going to need at least one more of each, and it needs to be a whole number. So I almost always add one more of the number that is an odd number so that I can get it to an even number. So PO₄, one more PO₄. I'm going to add one more of them. So 3 and 3, this is going to give me a 6. And I know 2 can go into 6, so I'm going to leave it alone because that's the lowest number that's even that 2 can go into. So it starts leading me towards that LCM method. Now, the question is, how many more 2's do I need to make 6? So if I add one more, 2 and 2 is 4. Oh, I need one more. Now I have 2, 4, 6. That also makes 6. So now that we're at 6 and 6, we know that's the lowest possible number, so we can count. I have 1, 2, 3 of these, so I put a 3 out front. That's called a coefficient. I have 1, 2 of these, so I put a 2 out front, so I can make sure that it's balanced. And then this coefficient becomes a subscript of cobalt. So it becomes CO3. I have more than one out here, so I need this in parentheses. PO₄. Each of the methods got me the same answer with a different thought process, and please use which one you're most comfortable with. Thank you so much for watching Always Eclectic Stacy. Please check out my other videos, and do not forget to like and subscribe. Thank you so much. Have a fantastic day.